Hello, good morning student. How are you? I hope you all are happy, healthy and fine at home. Did you remember what were we discussing yesterday? I think we were discuss about the application, synthetic application of acetoacetic ester while studying the synthesis of acetoacetic ester and its application. I think synthetic application so far we have learned I think 2 application. Now move on to the next one. Next application we are talking about acetoacetic ester, or it is known as ethyl acetoacetate or beta-Diketone ester. This acetoacetic ester is a synthetic reagent or versatile reagent, and this reagent is prepared by one famous reaction that is known as Claisen ester condensation. That is a simple Claisen ester condensation. Two same molecule treated in presence of sodium ethoxide resulting compound formed is a acetoacetic ester. There is a reactive methylene group is present, and that reactive methylene group present over there is a better stabilized than the malonic ester which we have learned in a previous lecture. So let's begin with the what we can call it as a synthesis of methyl cycloalkyl ketone. Synthesis of third one, synthesis of methyl cycloalkyl ketones. Methyl cycloalkyl ketones. As we know that ketone, the general formula of ketone RC double bond O R dash, or as we know that, right? Now if we use dialkylation instead of alkyl halide, we get methyl cycloalkane ketones. Understood this one? If we use dialkylation instead of alkyl halide, we get methyl cycloalkane, or we will get methyl cycloalkane, or we can get methyl cycloalkane. Now let us begin with the start compound is the ethyl acetoacetate, CH3, C double bond O, then CH2, C double bond O, OET. This is known as a acetoacetic ester, or we can call it as a ethyl acetoacetate, or we can call it as a beta-Diketone ester. This one, beta-Diketone ester, right? And starting from this, the question, how the question will appear in the exam, how will you synthesize the methyl cycloketone using acetoacetic ester. So this is a starting compound also given, target also given. Target molecule is nothing but as a final product also given. So your job is very easy. You have to treat that or give the sequence of the reagent, and you can achieve your target molecule. That is the ultimate. Or now the what is that methyl cycloketone? First one is a planning, right? And as we know that planning, how do you plan this? If you do the proper planning, then you can achieve the goal, or you can achieve your desired product, right? Now what is the desired product here? Methyl cycloalkyl butane. Methyl cycloalkyl butane structure CH3, C double bond O, then H I am writing like this, then CH2, here CH2, this is a cyclobutane, right? 4 carbon atom in the straight chain, in the cycle, and that's why it is called as a cyclobutane, right? CH2, CH3. Now, if you observe this structure carefully, what do you see? over here I am marking this part. This part as usual it is coming from the starting material which is acetoacetic ester. Now look at here, I am marking here hydrogen atom separately, that hydrogen atom which is coming from the hydrolysis process, right? And now this part, now I am marking here this part, this is the part which is coming from the alkyl halide. Which alkyl halide do you remember, or do you think this is coming from the dialkyl halide? Dialkyl halide, as we know that both the halide groups are present in the same organic compound, that is called as a dihalide. And now let's see here, now this is the analysis, this is the planning we have carried out here. We have analyzing this target molecule by and we have inferred that this part is coming from, we have definitely know that this part is coming from the acetoacetic ester, because they have been asked us to synthesize this target molecule, this is the final product. This final product you should prepare starting from the alkyl halide, right? Starting from the acetoacetic ester, not the alkyl halide. You should prepare the compound starting from the cyclobutane over here, synthesis of methyl cycloketone. Now let us look at here starting compound. They have given us CH3 C double bond O, CH2 C double bond O, ET. And now what is going to happen here, you treat this compound with sodium ethoxide, NaOT. And as we know that when we treat this starting compound acetoacetic ester in presence of the sodium with the sodium ethoxide, resulting compound form as a carbanion. So that is our ultimate, because we are discussing the chapter number 1. The name of that chapter is a carbanion and their reaction, and therefore first step should be the formation of carbanion. CH3, then C double bond O, here CH, one of the proton get abstracted by this, and sodium always is a positive in nature, C double bond O, OET. So this is a carbanion, and that carbanion is well stabilized due to the resonance, because that carbanion is present in between the two strong electron withdrawing group. And what will be the next step? Next step, this compound is treated with this one. I am writing by observing this. Here I am going to attach Br here also I am going to attach Br, means there are CH2, CH2, CH2. Look at here, because you have to think in this way, what will be the step, because first job to draw the correct structure of the final product, correct structure of the target molecule, and then you can work accordingly, so that here you will get here Br, then CH2, CH2, CH2 and the Br. That's it. Okay, now this negative charge is going to attack on that CH2, and Br is a departure, so that you are going to get over here CH3, C double bond O, then CH, then now is a CH2, then CH2, CH2 and Br attached over there, then C double bond O, OET in this way. Now what is going to happen? What will be the next step to do over here? Look at here, still there is one more hydrogen atom over here, and then you can use again sodium ethoxide NaOET. And as we know that the function of sodium ethoxide, it will abstract the proton from here and form the carbanion, and we are going to get here CH3, C double bond O, C minor charge over there, and now here this is a CH2, this is also as a CH2, CH2 and Br, and rest of the thing we can write as it is. Okay, understood this one? Now next one, what is going to happen? This carbanion is going to attack on that CH2, Br is a depart over there, and you are going to get over here CH3, C double bond O, then here C double bond O, CH2. I am writing this CH2 over here, CH2 and another CH2. This is a four-membered ring, obtained over here. This remains there. Now this compound, now we can do the hydrolysis over here. After the hydrolysis, ester group is converted into as a acid, and you are going to get here CH3, C double bond O, then here C, here you write CH2, another CH2, here CH2 and C double bond O and H, like this, right? And after that, what is the next thing to do? There is a decarboxylation. Hit it, there is a evolution of carbon dioxide, CO2, get removed from it. How it is removed? This sigma bond can form as a double bond over there. This double bond revolving around it and remains as it is. At the same time, this bond is broken and form as a carbanion at this point, and you are going to get CH3, then this now is a CH2, another CH2, one more CH2, and then there will be a negative charge, right? And when that negative charge over there, this negative charge, then in the next step, hydrolysis, H2O in presence of H plus. This process is known as a protonation. And after the protonation, if you carry out the protonation, what do you get? You are going to get over here this one. Here you will get CH3, then here C double bond O as it is, and here CH, one hydrogen atom which is coming from that, then CH2, and you can write as a CH2. This is a methyl cycloalkyl ketone or methyl cyclobutane ketone. So this is a compound we have synthesized by using as a acetoacetic ester, which is a starting material used for the synthesis of this compound. Now let us see one more example over here, so that we can prepare, we can synthesize that target molecule or the final product in the here by using the acetoacetic ester. Let us see fourth one, synthesis of gamma keto acids. Synthesis of gamma keto acids. Synthesis of gamma keto acids, but you have to know what type of the acid it is. So that is 4-oxopentanoic acid, that is called as a gamma keto acid. Gamma keto acid. This is a gamma keto acid. So at a gamma position, as we know that alpha, beta, and the gamma position there is a keto group. Let us first planning this. In every case it requires a planning. So here, as we know that CH3, then C double bond O, then one H I am writing here, and now one H, then CH2, then C double bond O and H. This type of the compound, because from this side this is acid group. This acid group, it is termed as alpha, beta, and this one is a gamma, and therefore it is known as a gamma keto acid. This one. This is a gamma keto acid. Now the planning. Now how do you plan this? Planning means what? You have to do the proper planning, then and then you can achieve, you can obtain, or you can derive the desired product. So planning must be. the question in an exam, how the question will appear, how will you synthesize the gamma keto acid using acetoacetic ester. Because at a T.Y.B.Sc level, remember, only two synthetic reagents we are going to use. By using these two versatile reagents, one is a malonic ester and another one is a acetoacetic ester. These are the two reagents. By using these two versatile reagents, variety of the different organic compound we are synthesizing in the here by using those things. Look at here, I am marking the sum of the part of this target molecule. Here one, and then marking I am like this. Look at here. Right. Now I made three parts over there. Now we are analyzing, and we are analyzing in a proper way. Look at the first part. I am marking this part, CH3 double bond OCH. If you observe carefully, where from this part is coming? This part is coming from acetoacetic ester. Remember, this part is coming from the acetoacetic ester. Now look at, here is a hydrogen atom. From where this hydrogen atom is coming? This hydrogen atom specifically or particularly coming from the solvent. During the protonation, whatever procedure, whatever reaction we are carried out, that is a protonation, that hydrogen is coming from that. And next one, this part, if you look at, if you observe this carefully, CH2 double bond OH, this acid part is coming from what? This acid part, if you remember, this part is coming from the alpha bromo ester, or alpha chloroester. Remember, alpha chloro, alpha bromo. During in a Re-Pharmacy reaction, we have learned this alpha bromo concept, right? There is a ester group, and at alpha position, suppose as a if you know the structure of that ester, suppose as this one, suppose we have this one, CH3 double bond OET, that is a ethyl acetate, right? This ethyl acetate, I am going to replace one of that hydrogen atom by Br. Then CH2 double bond O and OET. I am this. What I did over here, I have changed one of the hydrogen. I have replaced one of the hydrogen atom by halide group, particularly bromine group in this case. And what is this compound becomes? This compound now we are calling it as a alpha bromo ester, right? Alpha bromo ester, this one alpha bromo ester. And this alpha bromo ester, instead if we use alpha haloester, if we use alpha haloester instead of alkyl halide, we will get, or we can get gamma keto acid, right? Now let us see over here. Now this is the whole, what we can call it as a planning. You do the planning first, do the proper planning, and then you can get your desired, your expected product, your desired product you get. Now start the synthesis, and while starting as a synthesis, from where, which is the starting compound you are going to use over here, they are mentioning that you use the starting compound is acetoacetic, don't use anything else. Here particularly you use as a starting compound is acetoacetic ester. They have given that is a fixed, starting material is a fixed. By starting that, you have to achieve, you have to synthesize your final product over here. Now let us see over here, what is that? Here, as we know that the name of the starting compound CH3 C double bond O, then CH2 C double bond O, OET, that is acetoacetic ester, right? Acetoacetic ester, or it is known as a ethyl acetoacetate or beta-keto ester. Now this compound you can treat with sodium NaOET, sodium ethoxide. And what the sodium ethoxide will do here? Sodium ethoxide will abstract the acidic proton and form as a carbanion over here. CH3 C double bond O, CH minus charge, and then C double bond O, then OET. Most of the case, the first step must be formation of the carbanion, because that carbanion is well stabilized due to the resonance. And now what is the next step over here? Next step, do the Br, then CH2 C double bond O, OET. Bromo, what is that? Bromoacetic, that is a bromo ester alpha bromo ester over here. Now this negative charge is going to attack on that CH2. Br is a departure over here, and you are going to get this one, CH3 C double bond O, then CH, I am writing this CH2, then C double bond O, OET, and another one C double bond O and OET. That's it. Understood this part? Now what will be the next step? Next step will be the hydrolysis. Now here H2O in presence of H plus. This process is known as a hydrolysis. This process is known as a abstraction of that proton. And now what is going to happen? There are two ester group. Look, observe this structure carefully. What will see over here? There are two ester group, and after the hydrolysis, both the ester group is going to convert into acid. That's it. And here you are going to get CH3, then C double bond O, CH, C double bond O, OH, and here CH2, then C double bond O, OH. That's it. After the hydrolysis, what is happening? Both the ester group is converting into as acid group. Now in the next step, there is a decarboxylation, as we know that, minus CO2. After the heating, it is easily lose the carbon dioxide in this fashion, losing, so that revolving around it, negative charge on it, and what you are going to now, something is missing, right? Something is there, CH2 C double bond O. Now here, right, a negative charge, not this one. Let me make here, you keep this one as it is. Only decarboxylation I am writing as this. Decarboxylation will be carried out by this, not from this, because, and that's the make the correction over here. Now what is going to happen? Let us see over there. Here CH3 C double bond O, now CH minus. Now I am writing this bending group in a straight chain, so that you can get CH2, then C double bond O and OH, right? And now next step will be the protonation. H2O in presence of H plus, this will pick up the proton, and you are going to get CH3 C double bond O, CH2 and C double bond O and OH. This will be our final product, or what we can call it as a desired product, which we are synthesizing as a gamma keto ester. Got it? This is another way of getting as this one, gamma keto ester. Now let us move on to the next point. What is the next fifth point? We are going to synthesis of now Let us see here. Let me clean the board first. Then what we are going to synthesize over here. Let's see what is there. Now what we are synthesizing here, let's see. Okay, now fifth one, synthesis of gamma diketone. Synthesis of gamma diketone. Synthesis of gamma diketone. So do you remember what is the structure of gamma diketone or beta-diketone, we can call it as gamma diketone. Suppose here CH3, C double bond O, CH, then H2, C double bond O and CH3, right? That is a this is a adjacent carbon alpha, beta and gamma. At gamma position there is a carbonyl group, right? Now again, if you observe this structure carefully, what do you see, or what type of the question may appear in the exam? The question is like this: how will you synthesize gamma keto ester using acetoacetic ester? That is again is a planning here. Do the proper planning. Now while doing as a proper planning means we are analyzing, we are going to synthesize this target molecule, and that target molecule how we can prepare, from where we can join that part together so that we can achieve that target molecule. So that is nothing but as a planning analysis of that. I am marking over here again, right? I am marking here one part over here, another part here and another part over here, right? These are the part I am making. Now you tell me, now you are well aware of that fact. Look at here, CH3, C double bond O, CH. From here this part is coming, this part is coming from acetoacetic ester, right? This part is coming from acetoacetic ester, and this part, or let us see, this part is coming from protonation, this hydrogen is coming from protonation, and now CH2, C double bond O, CH3, this part is coming from alpha bromo ketone, right? This is alpha bromo ketone. Alpha bromo ketone. If we use alpha bromo ketone instead of alkyl halide, we will get this gamma diketone, right? Gamma diketone. Diketone means there are the two carbonyl groups are there, and this is the this is the planning we have analyzing that we have done the planning over there, right? Once you plan it, and now is the starting compound. What will be the starting compound you are going to use here? We must use as a starting group, because the question itself suggests that the starting compound you must use as a acetoacetic ester. Let us start the synthesis of this compound, and now acetoacetic ester will be our starting compound. CH3, C double bond O, then CH2, C double bond O and OET. This is our starting compound, is acetoacetic ester. And what is the first step? As usual is a sodium ethoxide. First treatment is a sodium ethoxide, right? Sodium ethoxide will attack the acidic proton, and you are going to get here CH3, C double bond O, CH minor charge over there, then C double bond O, OET, right? And once you prepare this, once you get this carbanion, and this carbanion is a well stabilized, because we have seen there are 4 factors which can stabilize the carbanion. Number 1, the percentage of S character of the carbanion. Number 2 is inductive effect. Number 3 is resonance effect. And number 4 is what is that? Number 4 is what type of the group it is? Number 4 is aromatization. These are them. Now here you can use Br, then CH2, and that is a C double bond O CH3, right? This is the compound which is a starting, which is a, instead of, if we use alpha bromoketone instead of alkyl halide, we can get our desired product. Now this negative charge is going to attack on Br. Br is a departure, and therefore you are going to get over here CH3, then C double bond O, then CH. I am writing here CH2, C double bond O, CH3, and rest of the thing C double bond O and the H, like this. Got it? Now, not the ester is still is there, OET as it is. Now next step will be the hydrolysis, right? H2O in presence of the H plus. Look at carefully, this process is known as a hydrolysis. And what is the hydrolysis? What do you mean by the hydrolysis? Hydrolysis convert the ester group. This is the ester group here, and that ester group is going to convert into as a acid, and we are going to get the product here CH3, C double bond O, then CH, C double bond O and H. Rest of the part of the organic compound, they are remains as it is. There is a CH3, and now we can do the next step will be the heating process minus CO2. Means this carbon dioxide is going to form as a carbanion over there. Here you are going to get CH3, C double bond O, then CH minus charge. I am writing this bending part is a straight one, so that you can understood CH2, C double bond O, CH3, right? And then you can carry out the protonation process. H2O in presence of the H plus, this process is called as the protonation. And once you carry out the protonation, what you are going to get? You are going to get your desired product CH3, C double bond O, CH2, CH2, and C double bond O, CH3, which is your target molecule, or what we can call it as it is your desired product. So in this way we have seen, I think last one we are going to see synthesis of beta-diketone by acylation. And now the last one is we are going to do the synthesis by using as a acetoacetic. Here we are did most of the thing over here, and now you are able to synthesize any of the target molecule or the final product using acetoacetic ester. Let us see synthesis of beta-diketone. Synthesis of beta-diketone. Synthesis of beta-diketone, or what we can call it as acylation, or you can call it as acylator. This is a 6 number, 6 synthetic application. And now synthesis of beta-diketone, most of you might be knowing as a beta. The synthesis of beta-diketone, let me write here CH3, then C double bond O, CH, 1H I am writing over here, and then this C double bond O and CH3, right? So this is nothing but, this is alpha, this will be the beta. It is called as a beta-diketone. Why di? Because there are the two carbonyl groups are there, and therefore, and as we know that beta-diketone are versatile compound, variety of the organic compound we can prepare by that compound also, and therefore this is the compound we can synthesize, we can prepare by using ethyl acetoacetate or the beta-Keto ester. Now let's start the synthesis over here. Here we have CH3, C double bond O, then CH2, C double bond O and OET, right? That is called as acetoacetic ester. Acetoacetic ester or ethyl acetoacetate. Ethyl acetoacetate, or we can call it as beta-Keto ester. Keto ester, which is our starting material as usual. And this compound, when it is treated with first one, sodium ethoxide, OET, and as we know that sodium ethoxide is a base, it is abstracting the highly acidic proton and resulting the formation of the carbanion, and that carbanion specifically is a highly unstable due to the presence of minus I inductive effect and the minus R inductive effect, OET. So this is the carbanion form over there, and this carbanion is well stabilized due to the resonance. And next one, here you have to treat this compound with Br, C double bond O and CS3, that is, or we can call it as a acetyl chloride, right? Here this is known as acetyl chloride. It's a better reagent which is available, or we can use it. So now what is going to happen? This is going to attack on this carbonyl group, is revolving around it, and HCl fumes goes in the atmosphere. So finally you are going to get CS3, C double bond O, then CH, here C double bond O, and CS3, here C double bond O, and OET, we got it, right? Now, and after that, what is our next step to do? Next step will be the hydrolysis. As we know, H2O in presence of the H plus, this process is called as a hydrolysis, and hydrolysis is a process which can convert the ester group into as acid. That is the meaning of hydrolysis. So after the hydrolysis, we are going to get here CH3, C double bond O, then CH. This C double bond O acetone remains as it is, this acetyl group, and here C double bond O and this H is there, right? And after that, and as we know that next step will be the heating. There is a decarboxylation. This process is called as the decarboxylation. Decarboxylation means what? Removal of the carboxylic group from the this molecule, and it is moving like this, and therefore you are going to get over here CH3, C double bond O, CH minus charge, C double bond O, CH3, and that's the it. Now next step will be the H2O in presence of H plus, that is again this step is known as a protonation. And what the protonation do? Protonation means it will abstract this carbanion will abstract the proton from here. This is acting as a base in this case, CH3, C double bond O, then CH2, then C double bond O and CH3. Let me clear one point over here. Now this is the carbanion, right? And this is not the carbanion. This is act as a base over here. What is the function of base? Which will abstract the proton from here and resulting into as a neutral molecule. Because as we know that carbanion means what? Carbanion means forming as a new carbon-carbon double bond. New carbon-carbon bond should be formed there. New carbon-carbon bond. But when that negative charge attacking on proton resulting into as a neutral molecule, this kind of the molecule, there is no new bond, no new organic compound. But here when carbanion attacking on the another species, there is a formation of the new carbon-carbon bond. At that moment, at that time, we can call it as a nucleophile, and here the negative charge over here, this we can call it as a base. because base which will abstract the proton and resulting the compound is a formation of this one. I think with this we have seen synthetic application of acetoacetic ester, malonic ester, and last point remaining in this chapter is what is that? Wittig reaction, and that reaction and what are the important question may appear in an exam, that I will discuss in the next lecture, tomorrow's lecture. I think with this, let us stop today here. Remaining we will see next time. Thank you. Have a nice day.